We've all heard of black holes, terrifying objects in space that devour everything, even light, never letting anything escape. But what if there was a cosmic mirror to the black hole, an object that does the exact opposite? Instead of sucking matter in, it expels it. Instead of hiding information, it throws it out. A place where nothing can enter, but everything pours out. These theoretical objects are called white holes, and they may be one of the weirdest and most fascinating possibilities in modern astrophysics. In this episode of Infinity Beyond, we're diving into the explosive, mysterious, and potentially real world of white holes, the cosmic opposites of black holes. What is a white hole? A white hole is a hypothetical region of space-time that acts as a reverse black hole. A black hole pulls everything in and lets nothing escape. A white hole expels matter and light, and nothing can go in. Imagine a cosmic fountain, endlessly spewing out radiation and matter, but completely impenetrable from the outside. White holes violate time symmetry in the opposite way black holes do. If you reverse the flow of time through a black hole's equations, you get a white hole. They're not just science fiction. White holes are a mathematical solution to Einstein's equations of general relativity. But do they exist in the real universe? That's where things get weird. A mathematical mirror. Black holes and white holes are connected through what's known as a maximally extended solution to the Schwarzschild metric, a mathematical description of space-time around a massive, non-rotating body. In this solution, a black hole is linked to a white hole through a wormhole, a theoretical bridge connecting two regions of space-time. This bridge is sometimes referred to as an Einstein-Rosen bridge. In theory, an object falling into a black hole could emerge from a white hole somewhere else in the universe, or in another universe entirely. But there's a problem. These bridges seem to be unstable. They collapse too quickly for anything to pass through. Still, they offer an astonishing picture. Black holes as cosmic drains, white holes as cosmic springs. Are white holes real? So far, no white holes have ever been observed. They remain a speculative concept, a consequence of mathematical symmetry, not physical evidence. But some physicists suggest that white holes could explain certain cosmic phenomena. For example, some gamma-ray bursts, powerful explosions from deep space, might be the result of short-lived white holes expelling energy. White holes might be connected to dark matter, the mysterious invisible substance that permeates the universe. They could be remnants of dying black holes, transforming at the end of their lives into white holes that release their contents. The idea of black holes turning into white holes is especially intriguing because it could solve one of physics' most pressing mysteries: the information paradox. Black holes raise a disturbing problem in quantum physics. When something falls in, its information seems to be lost forever. This violates a fundamental principle of quantum mechanics. Information must be conserved. So what happens to the information swallowed by a black hole? Some physicists, including Stephen Hawking, have suggested that black holes might not erase information after all. Instead, they may eventually release it back, somehow. One radical idea: at the very end of its life, after evaporating via Hawking radiation, a black hole bounces into a white hole, expelling all the trapped information. This leads to a beautiful possibility: that white holes are the final act of black holes. They could be the key to reconciling gravity and quantum mechanics. Loop quantum gravity and white holes. One of the theories exploring this transformation is loop quantum gravity, an alternative to string theory. According to this idea, space-time is not smooth and continuous, but quantized, made up of tiny loops of energy. In this framework, the collapse of a black hole doesn't lead to a singularity. Instead, it reaches a minimum size and rebounds, forming a white hole. This process could happen very quickly from the black hole's point of view, but appear to take billions of years to an outside observer. If true, white holes might be all around us, hiding inside the remnants of dead stars, waiting for their moment to burst open. Could the Big Bang have been a white hole? Here's a truly mind-blowing idea. What if our entire universe emerged from a white hole? The Big Bang looks suspiciously like a white hole event, a sudden, massive expansion of energy and matter from a single point. Some theorists suggest that our universe might be the interior of a white hole formed from the collapse of a star in another universe. This is speculative, but deeply compelling. It would mean we live inside a white hole, born from another reality, part of an eternal cycle of cosmic births and deaths. Philosophical implications. If white holes exist, they force us to rethink the nature of space, time, and information. They may represent the arrow of time, pointing outward, dispersing, expanding, rather than collapsing inward. They may be evidence of mirror realities, universes that are time-reversed reflections of our own. Or they may simply be reminders that our understanding of physics is still incomplete. In a cosmos filled with mysteries, white holes stand as one of the boldest and least understood. Final thought. White holes are strange. They're unpredictable, untouchable. They spit out matter, reject entry, and defy easy explanation. But they also represent a beautiful symmetry, the idea that for every sink, there might be a spring. For every collapse, an explosion. For every end, a beginning. Whether real or theoretical, white holes push the boundaries of what we consider possible. And here on Infinity Beyond, that's exactly where we like to be.